All right, let's look at section 10.1, which is on the law of sines. Now, the law of sines and the law of cosines, which we'll see in 10.2, are a little different than the trig we've been doing because these actually apply to all triangles, not just right triangles. So, just a reminder: whenever we draw a triangle, we label the three angles with A, B, and C, and we label with capital A, B, and C. And we label the sides with lowercase a, b, and c. And for a given letter, the lowercase and uppercase are opposite each other. And so given that, what the law of sine says is that for any triangle, this holds right here. A divided by sine A is equal to B divided by sine B, and that's also equal to C divided by sine C. Now this is the way it's always written, but you can use it like this. You could put the sines on top and the lengths of the sides on bottom, and it works just as well that way. But this is traditionally how it's written, so that's how I'll write it. All right, let's talk about solving a triangle. A triangle has three sides and three angles. That's obvious, but that's 6 pieces of information. And usually, if you're given 3 of those pieces of information, that's usually enough for you to be able to figure out the other 3. And so we classify these types of problems by which 3 pieces of information you're given. And we also classify them by the order in which it's given to us. And here's what I mean. Let's compare these two. The angle side angle problem, ASA, and the side angle problem, SAA. On both of those, you're given one side and 2 angles. But the ASA problem, you're given, let's say this is your triangle, you're given an angle, a side, and an angle that are, sort of in order going around the triangle. Angle, side, angle. And if you look at a side angle angle, on those, you're given a side, and then an angle, and then another angle. So it's like the difference there is where the side is. On a side angle angle problem, the side's down here, or, well, the important thing is it's not between the angles. On an angle side angle, the side given is between the angles. So anyway, that lets us classify the types of problems we have into these. Now the ones we're going to look at today are the angle side angle, angle, and angle side side. Those are the 3 that we can solve just using the law of sines. The others, the side angle side and side side side, those require the law of cosines. And angle angle angle, you can't really solve that. The reason is, if you're given 3 angles, say 45, 45, 90, that doesn't tell you anything about the side lengths. 45, 45, 90 could be this, it could be something bigger, so you get infinitely many there, and they're all similar to each other. So what I want to do in this section is talk about 2 things. I'm going to break it into 2 parts. First up, we're going to talk about the ASA and the AAS. And we're going to save the ASS for the next video, because those are a bit of a pain. What do I mean by a pain? Well, sometimes you get no solution, sometimes you get 2 solutions, sometimes you get 1. So let's just start here looking at angle side angle and angle angle side problems. There's not a whole lot to go wrong on these. Let's say we wanted to solve this triangle here. All right, so first up, we have to look at it and see which one of these do we have both an angle and the side opposite of it. And on this one, it looks like, actually, we don't have any of those. But given that this is 50 and this is 33.5, we can figure out what B is. B is going to be 180 degrees minus 50 degrees minus 33.5 degrees. So that's 180 minus 50 minus 33.5. That's 96.5 degrees. All right. And so once we've got that, now we can use the law of sines to figure out A and C. So let's get A. What I know is little a over sine A is equal to little b over sine B. So I get that. So little a is 76 times sine 50 degrees over sine 96.5 degrees. And I'm just going to use my calculator to do that. So 76 times sine 50 gives me that, divided by sine 96.5 gives me a number here, which is 58.59. I'm going to round that to 58.6. So let's see, that's one of my bits of information. This is one, and the thing left to solve for is little c. So let's see, little c over sine c. Let's see, what is sine c? C is 33.5 degrees. Equals. Now I could use A or B here. I don't want to use A. I want to use B. In theory, I could use either one, but this is a rounded number, so it's already lacking some precision. But the B equals 76, that's exact. So let's use the exact number so that we don't have to worry about round-off error. So I'm going to use B, 76, over sine 96.5. And so I get C is equal to 76 sine 33.5 degrees over sine 96.5 degrees. And let's work that out. I'm actually going to do this on a different calculator. I've been using my little single line calculator, but if I use this, I can type it all in one line. First off, make sure I'm in the correct mode. I'm in degree mode. So it's going to be 76 times sine 33.5 divided by sine 96.5. That gives me 42.2. All right, and that's pretty much all there is to it. Let's see. I've got several more examples, but I think I'm going to put those in the next video.